We have 5 basic steps for solving a word problem. The first is familiarize yourself with the problem. Translate the mathematical language, in other words, write an equation. Solve the equation, check your answer in the original problem to see that it works, and then be sure that you answer the question and state your answer clearly. To dig in to this procedure a little bit deeper, we have some additional hints. And the first one is read the problem carefully. Speed reading is not your friend when it comes to word problems. Try to visualize the problem. If drawing a picture helps, by all means try that. Reread the problem, underlining key terms that you feel are pertinent to solving the problem. List the information given and the questions. Choose a variable to represent the unknown. Look for similarities between problems you have already solved. If it follows a certain pattern, try using that pattern or type of problem that you've seen before and solving it. Make a table, look for patterns, make a drawing, and if all else, punt. Taking some time away from the problem and coming back is a good suggestion as well. Let's see about solving some word problems. The U.S. interstate highways post number markers every mile to indicate location. The sum of 2 consecutive mile markers on I-70 in Kansas is 559. Find the numbers of the mile markers. To solve this problem, we need to know what is being asked. The question or problem is for us to determine the numbers of those mile markers. They're telling us that these mile markers are consecutive, in other words, one number after another. We're now ready to set up our unknown. We're going to let X stand for the first mile marker, and the next consecutive number would be X plus 1 will represent the second mile marker. We're now ready to translate the mathematical words here into operations and create an equation. We see 2 key words here, the sum of those 2 consecutive mile markers, and that it is 559. This will be the basis of our equation. Sum is the term given to the result of an addition problem. So we're ready now to set up that equation. The first mile marker plus the second mile marker represented by the variables established prior to this is equal to 559. Simplifying this equation, the parentheses have no effect. We'll combine like terms. X plus x makes 2x. Solving for the variable and working backwards through the order of operations, subtract 1 from each side. Last, undo multiplication with division, divide both sides by 2, and we end up with x equal to 279. X stood for the first mile marker, so our first mile marker is at 279. Our second mile marker is x plus 1, or 280. And of course we'd want to check to make sure that these do in fact add up to be 559. Let's take a look at this second problem. Copier rent is $225 per month plus 0.012 of a dollar per copy. How many copies can be made in a 3-month period if there is a budget limit of $1,100? One of the first things we can do is identify what they're asking us. And the question is how many copies. From there, we'll let X stand for our unknown. We want to pull together the information that's given to generate our equation. And in this particular problem, there's quite a bit of information. We know that the sum of this copying bill has to equal $1,100. The bill is generated from the $225 flat fee per month plus that charge per copy. The other detail here is that this budget is for a 3-month period. Putting these pieces of information together into an equation, we have the following. 3 months at a flat $225 per month fee plus this charge of 1.2 cents per copy and we let x equal the number of copies, will equal our budgeted amount. We're now ready to simplify the equation and solve for the variable. First, we'll simplify the indicated multiplication. To solve for the variable, we will subtract 675 from both sides of the equation. And last, to solve for x, divide both sides by 0.012 for a final answer of approximately 35,417 copies. Of course, it's important that we check this answer and express our answer in the correct form. In this problem, it states that Doug paid $72 for a shock-proof portable CD player during a 20% off sale. What was the regular price? Again, investigating what is being asked of us, we see the question is asking for the regular price. Oftentimes, letting the variable stand for the unknown is a good place to start. And so we'll let x stand for the regular or original price. Next, looking at other key pieces of information, we see that Doug paid $72. Next, we see that it is 20% off. Putting these values together, we have the basis for our equation. We don't know the original price, which we set equal to x. We have information that it was 20% off, so we'll take 20% of the original price, and off means that original price was reduced by that, and we set it equal to that sales price that Doug paid. Simplifying, we're going to combine like terms. 1x minus 2/10x leaves 8/10x, and to solve for the variable, undo multiplication with division of 0.8, arriving at x is equal to 90. $90 then appears to be the original price, and again, it's important that we check our answer to make sure we're answering the question and that we have solved it correctly.